Have you ever felt the ground shake? That's the power of an earthquake, a reminder that our planet is alive and always changing. The Earth's surface is like a giant jigsaw puzzle made of tectonic plates, slowly moving atop a softer layer below. Most earthquakes happen when these plates get stuck, pressure builds, and then suddenly releases like snapping a bent stick. This energy travels as waves, shaking the ground and sometimes causing destruction. These quakes usually occur in the brittle crust, close to the surface where rocks can break. For years, scientists thought earthquakes only happen near the surface where rocks are crunchy and breakable. But then, they started detecting earthquakes much deeper, hundreds of kilometers down in the mantle. Down there, the pressure and temperature are extreme. Rocks should bend, not break. So how could earthquakes happen in a place where everything should just flow? This mystery challenged everything we thought we knew about our planet's inner workings. Deep focus earthquakes became a puzzle hinting at unknown forces far beneath our feet. What could cause rocks to snap so deep underground? The answer would change our understanding of Earth's dynamic interior, and it all started with a record-breaking event that shook the scientific world. Let's dive deeper to uncover the secrets of these hidden tremors. On May 30th, 2015, deep beneath Japan's remote Bonin Islands, an extraordinary earthquake struck. Seismometers worldwide picked up the magnitude 7.9 quake, so powerful, people in Tokyo felt buildings sway for a full minute. But what stunned scientists was its depth, 751 kilometers below the surface, nearly twice as deep as the International Space Station is high above us. This was the deepest earthquake ever recorded, shattering previous records and scientific expectations. At that depth, rock should behave like plastic, bending and flowing, not snapping. Yet, the Bonin Islands quake proved otherwise, a geological paradox. It was as if a piece of ice had formed in a furnace. How could rock break in such an environment? This event forced scientists to rethink the rules of geology. The Bonin Islands earthquake became a clue that there are new, mysterious processes at work deep inside our planet. It was a message from the deep, urging us to look closer. So what's really happening down there? How can earthquakes happen so deep, where rocks should be soft and unbreakable? The answer lies in subduction zones, where one tectonic plate dives beneath another, carrying cold, rigid rock deep into the mantle. Inside these sinking slabs is a mineral called olivine. As the slab plunges, pressure forces olivine to transform into denser minerals, a process called a phase transition. Sometimes this change happens suddenly, releasing energy in a burst, an implosion, not an explosion. This rapid transformation can trigger a deep earthquake even without the rock snapping like at the surface. Another theory: intense stress creates tiny, super-hot zones that momentarily melt, letting the fault slip and release energy. So deep earthquakes aren't just about breaking rock. They're about mineral transformations and extreme conditions. It's a complex dance of pressure, temperature, and chemistry. These hidden processes allow the unbreakable to break. Each deep quake is a clue to the strange physics of Earth's interior. And with every discovery, we get closer to understanding our planet's deepest secrets. But how do we study something so far beneath our feet? We can't drill 751 kilometers underground, so scientists rely on seismic waves, vibrations that travel through the Earth. Seismometers across the globe record these waves, allowing scientists to pinpoint where and how deep an earthquake occurred. The 2015 Bonin Islands quake was so powerful, its waves were detected worldwide, giving us a precise look at its record-breaking depth. Seismic waves also reveal what's inside the Earth, changing speed and direction as they pass through different materials. By analyzing thousands of earthquakes, scientists create 3D maps of the planet's interior, a technique called seismic tomography. It's like giving Earth a CT scan, revealing hidden structures and cold, sinking slabs. Now, artificial intelligence helps sift through massive data, spotting tiny, deep quakes once lost in the noise. Machine learning uncovers patterns and connections, giving us a clearer view of the deep Earth than ever before. Each new quake adds a piece to the puzzle. The more we listen, the more we learn about our planet's mysterious depths. And the discoveries keep coming. Could earthquakes happen even deeper than 751 kilometers? Maybe, but the conditions become even more extreme. Most deep quakes occur in the transition zone, ending around 660 kilometers down. The Bonin Islands event was already far below that, making it truly unique. As slabs sink deeper, they heat up and blend into the mantle, likely losing their ability to trigger quakes. So, we may be close to the ultimate depth limit for earthquakes. But why does this matter? Deep earthquakes are our only direct window into the planet's interior. They reveal how heat and materials circulate, driving plate tectonics and shaping our world. Each deep quake tests the limits of our knowledge and refines our models of Earth. The Bonin Islands mystery is more than a record. It's a quest to understand the heart of our planet. And that journey is just beginning.